Hi, welcome to the webinar on VLANs. What are they good for? I'm Gabriel Reyes. I'm the sales engineer here at EnGenius, and I'll be going over this webinar for you. Thank you for attending this webinar as well. Okay, so first let's get started with some housekeeping measures. Sorry about that, housekeeping measures. So let's talk about the partner benefits, the standard Ethernet frames, 802.1q frame, the VLAN solutions, and then we'll follow it up with some questions and answers. We're also going to have a demonstration where I'm actually going to set up VLANs for you, at least 3 VLANs from scratch. So that should be fun. Okay, so these are the partner programs that we have to offer you. The options that are in there. We have the Easy Wi-Fi Planner. You have access to the support number, special dealer pricing, certification trainings, which will be revised and added in 2019. We're very excited about that. If you listen to this and you're not a partner, you can always become a registered EnGenius partner by going to partners.engeniustech.com. And all you do is sign up for your company account first, then sign up for the user second, and then you now have access to all these great and wonderful features that all the registered partners have access to. Without further ado, let's jump right into the meat and potatoes of this. So before we start talking about a standard Ethernet frame, we have to do some networking fundamental refresher really fast. So no matter in networking, when you're learning it, no matter where you turn, at some point you're going to run into this. You're going to run into the OSI model. So what is the OSI model? Well, the OSI model basically is a model of a representation of a networking stack. So for example, back in the days, in the 80s, early 90s, we used to have multiple competing networking stacks. OSI was actually one of them as well back in the 70s, but they deprecated it. TCP/IP was one. We had Novell as another one. We had DEC. We had all these competing networking stacks. The one that won out, as everyone knows, was TCP/IP. But the whole point of having a networking stack is that if I want to create an application, I don't want to create an entire new networking stack for either the application or the different routing protocol that's being used to be routed on the internet, or between different physical layers. For example, if I wanted to go off DOCSIS, coax, I don't want to write a whole new protocol in order to run off DOCSIS. If I wanted to run off Ethernet or copper, I don't want to write a whole new protocol for that, or fiber or wireless and so forth and so forth. So this allows the stack to be modular, in which I'm able to remove some portions and move other portions in without impacting the other layers, which is very important, which means that in the future, if we have other networking, either protocols or networking mediums, communication types to put it on, we don't have to write a whole new stack for it. So it makes it much more modular, much more flexible. That's the whole point of the stack. Now, every single layer has a particular addressing type for it, and it has a different layer number. For example, I'm referring to layer 2 as the data link layer. Okay, well, the data link layer would be layer 2, which is obviously data link. So 7 would be application, 6 would be presentation, 5 would be session, 4 would be transport, 3 would be network, 2 would be data link, and 1 would be physical. On the left-hand side, you can see what we normally call these. The physical layer, layer 1, would be called bits or signaling. Layer 2 would be called frames. Layer 3 would be called packets, or what people are familiar with, IP addressing, which is at layer 3. Transports, which is segments. Most people know them as ports. So that's layer 4. And all these have different addressing on them. So one important thing to note is that at layer 2, we actually have a sublayer. It's called the MAC and the LLC. So the MAC is called the Media Access Control, not to be confused with the MAC address, because that's completely different. Media Access Control sublayer, what that does, it actually encodes the information to transfer to the physical medium. Now that needs to get handed off somewhere, because the only one that's physical in this, that tangibly exists, is the data link and the physical. All the other ones up, which are northbound of the stack, is going to be logical. So the link between the logical ones are the LLC, which is the logical link controller. So that's how the logical bridges to the physical. Okay, so now let's talk about the MAC addressing, because this is important for Ethernet layer 2 addressing. So as I put in here with parentheses implies Ethernet, when I say MAC address, I'm saying it's Ethernet type 2 or Ethernet type, and it's also running off copper. Ethernet can be run off different types of physical mediums as well beyond copper, like Metro Ethernet and stuff of that nature. and so can IP addressing be run off different, layer 2 types. So when I say MAC address, I'm pretty much saying Ethernet type for copper. If I were to talk about, let's say, Wi-Fi, I would say it's a BSSID address. If I were to talk about Bluetooth, it would be something else. So that's just a shorthand way of me just telling you, hey, it's a layer 2 address, Ether type, and it's also on copper. So the MAC address is a 48-bit address. It's unique to the network interface adapter, and because it can be virtual or physical, and it's expressed by 12 hexadecimal digit number, alphanumeric. It's base 15. Sorry. So it could be numbers 0 to 15, in addition to the letters A through F. So for example, one of our devices would have a MAC address of 88DC961 Echo 7 Alpha Foxtrot. So that would be the unique identifier at layer 2 for that particular device. And that one would actually, the first half of the address we call the OUI, which is called the Organizational Unique Identifier. So what that tells me is if I'm a manufacturer, I need to go to a registrar, register that half of the MAC address so that when any other person wants to identify who the vendor is based upon layer 2, they could reference that table and they know who the manufacturer is. Multiple OUIs could be for one vendor if they manufacture a lot of networking equipment. Intel's one of them. We actually have 2. Our current one is 88DC96, but our old one is 00026F. So if I were to say the first half of those MAC addresses to you, you would know that it's an EnGenius device. That's how devices are able to be identified, which in the packet captures, I'll show you later on with Wireshark, they use the OUI to identify the manufacturer as well. Okay, but before we move on, we need to have some terminology that we're going to be describing certain concepts. Now, some of these terminologies are vendor proprietary, or they're going to be in certain vendors. They may change the name, but the concepts are pretty much the same. So the one that's pretty much universal is ONTAG. Pretty much it's just standard Ethernet frame. We're going to show you what that framing structure looks like, field by field as well, or header by header. And then we have something called an access. So when I say access, and this changes between vendors, when I say access, that means I'm going to be sending inbound and outbound on the switch port. It's going to be ONTAG for one particular VLAN. When I first take the switch out of the box, all of them are access layer ports for VLAN 1. But I could change it so they could be access layer for VLAN 2 or VLAN 3. I could change that. Access just means ingressing and egressing, so inbound and outbound of that switch port is going to be ONTAG for whatever VLAN I choose. And then we have tagged, also called 802.1q frame. A tag is basically additional header added to a standard Ethernet frame, but it has certain subfields within that, and it changes a lot of things in which we're going to show you the structure and how it's going to be impacted in later slides. And then we have something called a trunk. Trunk basically means I have a switch port and I have at least one tagged network or VLAN coming in and out of that port, inbound and outbound, and one untagged coming inbound and outbound. If I have that scenario, then technically I have a trunk. Now, different vendors may call it different things, but conceptually it's a trunk. A native VLAN means whatever on-tag VLAN within the trunk is considered the native VLAN. Now that could be any VLAN I choose. That could be VLAN 4, 5, 6, or 7, and that could choose for every single switch hop. Now, normal convention for design for VLANs is that you want to maintain the native VLAN across the switching fabric because you don't want to be confused by it. But technically, you can change it. So when I say native VLAN, that basically means the on-tag VLANs coming across a trunk link. And some kind of people call it a management VLAN as well. Okay, so now we're going to get to what the standard Ethernet frame structure looks like. All right, so this will be a standard Ethernet frame structure. And one thing I wanted to talk about is two fields, is the preamble and the FCS, before we start diving into what the other fields are. So the preamble is pretty much the same on an 802.1q frame or a standard Ethernet type 2 frame. Basically, it's like sequencing and timing to make sure that the devices that are receiving the frame are synchronizing with each other so they know that when information comes, what structure it should go into. For example, if I'm off sequence or skewed, I may place information in the data in the source address, or information for the source address in the data, and that's going to interrupt my FCS check, and that's going to cause a corrupted frame. So you have to make sure that it's timed correctly. And there's a subframe within the preamble frame called an SFD. It's not labeled here, but it's there. It's called start frame delimiter. Basically, after all the timing, it's getting the structure set up for Ethernet, and then it's saying, okay, you're getting ready for Ethernet. This is what the structure should look like, and there you go. And right after the end of the SFD, you have the first half, which is the destination address. And so the FCS, I mean, we have it right here. It's ran over the destination address, the source address, the length, the type, and the data fields. But that's going to come into play further on. I'll explain more about the FCS before we start talking about 802.1q frame. Okay, so the basic frame structure is we have the sender of the frame. In this case, it is the MAC address of 30 Bravo 5 Charlie 2 Delta 7 Charlie Alpha. That is the sender of this particular frame. Now, it's got to be sent somewhere. So it's got to go to a destination, which is the recipient of the frame. So in this case, it is something that is the OUI identifies as a magic con, and the full MAC address is 00051 Bravo Alpha 1374 Charlie. So Wireshark has identified the OUI of 00051 Bravo as, in the registrar list it has in its database, as registered to magic con. So the source is going to go to the destination. Okay, in this particular type of frame here, we have the type. Now, when I say type is because there really is different types of Ethernet. The one that everyone knows now that we currently use is Ethernet 2. So the type field now used to identify whether it's Ethernet 1 or 2, but now since everyone agrees that they're using Ethernet type 2, the type is now an extension of the data field. So basically it's telling you, hey, this is pretty much what we have in the data field. Right now it's identifying it as IPv version 4. That's in the data. So that would be in hexadecimal 0800. And then we got the payload. In this particular case, we know that it's Ethernet. We know it's Ether type of type 2. We have an IP, which is TCP/IP version 4. And we know the layer 4 type 2, which is UDP. But beyond that, we have no visibility, so it's just data. If you want to know what the data was, further on in Wireshark, further down, you would have that information. Okay, so now we need to start talking about 802.1q frame, but before we talk about that, I need to go over the FCS. So the FCS stands for a frame check sequence. What it does is it does something, an algorithm called a CRC, called a cyclically redundancy check. Basically, it's the error detection at layer 2. In Ethernet, Ethernet has error detection. Error correction is left up to the upper layers, like layer 4, like it's a TCP, UDP. In this case, it's a UDP, so there's no sequencing, acknowledging, windowing, anything like that. It's not going to be on this particular frame type because it's UDP, not TCP. But how the FCS is determined is basically there's an algorithm that's run, and it's run across the destination address, the source address, the type, and the data. And from that algorithm, there's this particular number that is derived. That number is placed in the FCS field, and the sender sends it off. Now, the receiver runs the same algorithm across the same field types. It should come up with the same number. If it does not come up with the same number, it could conclude that there's either data missing, data added, or data corrupted. And so it's going to silently discard the frame. Now, when I say silently discard the frame, it means there's no notification that this has occurred, and there's no positive acknowledgement back to the sender that this is the case. So when you're doing Wireshark captures and you're seeing data coming out at layer 2 but not coming in, you need to look at the upper layer protocols to see whether or not there's any error correction being done, because it's going to be invisible to you at layer 2. So this is the reason why it's important when we start talking about 802.1q frame, because if you look at the frame structure, 802.1q, it actually adds a new header with subfields in it. It adds a 802.1q. So now the FCS is run across the destination address, the source address, the new header, the type, and the data. So if I was a client and I'm all looking for on tag and I receive a tag, I'm going to look and see, hey, too much information has been added. I'm going to silently discard that frame. And so I will not understand the 802.1q framing. And that's the reason why it's important that you have a 802.1q capable device in order to send 802.1q frames there to send that across the network. So it has the same fields you do in the standard one. You have the source address, You have the destination address. And then you also have a new field here, which has been added, which is the 802.1q field. So in this field, there's also different, this header is different subfields. There's priority, there's DEI, and there's an ID. So based upon this, I could see that the actual VLAN ID that this is tied to is VLAN 100. So I know that this is traffic for VLAN 100. The priority is basically how we get something called COS values, which is class of service. So it's traffic prioritization and discrimination at layer 2. That's, in order to have that, you have to have an 802.1q header in order to have that particular subfield, the priority field for that. Without that, the only way to actually start getting prioritization of traffic on the network is QoS, which is done at layer 3. So that priority sets a priority value. The DEI is a 1-bit flag, basically tells it whether or not if there's any congestion to drop me or not. So if, am I higher priority, am I lower priority? That's basically what the DEI is. In here, it's set to 0, so it is eligible to be discarded if we have too much congestion on the network. And then we have a type field. In this case, it's actually the field above the one that's highlighted, but as you can see, the hex value, it is different than the Ethernet. It's actually 8100. That's actually the field that identifies that, you know, that this is actually 802.1q. If you look below the VLAN 100, you'll see we still maintain the type. The type is still 0800. So this is showing you that we've actually added a 802.1q header before the type header within the actual packet capture. And it matches the structure we have at the bottom. Okay, so now let's talk about the VLAN deployment. All right, so if I did not have VLAN and I wanted to have multiple networks, I would have to do a setup similar to the one shown here, in which I have to have 2 WANs, 2 routers, one for the guests, one for the staff, 2 separate cable runs to 2 separate switches to more 2 separate cable runs, 2 separate access points. As you can see, this really increases your CAPEX and your OPEX because you have to spend more initially. You have to spend double or triple depending on how many networks you want to be segmented, as well as the cost of operating them, administrating them, power draw, administrative of updating the firmware. All that stuff has to be taken into account. So this, as you can see, this does not scale well when you start wanting larger networks or multiple networks within your network. So how are we going to resolve this? Well, one way of resolving this and keeping the segmentation that we need at layer 2 is actually VLANs. In this particular case, we lower our CAPEX and OPEX because we're still using the same infrastructure that we have. We're just putting an inter-VLAN router, a VLAN switch, and a access point that's capable of understanding the tags. It scales very well. I'm able to have multiple networks done the same network infrastructure. I'm leveraging that same network infrastructure. And I still have the traffic segmentation I desire at layer 2. So the start of network security is because those are segmented at layer 2. So that means if someone is looking for VLAN 200, they're going to ignore VLAN 100. And that's how you get the segmentation. Now, it's important to note here that the VLAN switch is a layer 2 switch. In this case, it's not going to do any VLAN routing. So it's basically going to just touch the tags at layer 2. So if something is sent to it as untagged, it'll add a tag or remove a tag. That's not doing VLAN routing. That's just manipulating the tags. If you want to control traffic between the VLANs, you need something called the inter-VLAN router. That's actually going to handle the traffic between the VLANs. So the VLAN switch will handle the tagging portion of it, and the inter-VLAN router will handle the traffic within the VLANs. So it's important that when setting up VLANs, that you actually have an inter-VLAN router. We say that because our switches are layer 2, and sometimes that's a common misconception. People think that we can actually route between the VLANs, and ours do not because they're just layer 2 switches. Okay, so now what we're going to do is we're going to do a demonstration. We're actually going to show you how to set this up from scratch. So the one we're going to do is basically this network right here. We have a management VLAN, which is going to be on tag, the native VLAN. We have a guest VLAN, which is going to be tagged. And then we have a staff VLAN, which is going to be tagged as well. And they are also going to be connecting to devices that are going to be untagged. So as you can see, the guests and the staff go to particular type of servers or services that are going to be hooked up to access layer ports, which are untagged. Now we're going to be having a tag port, in this case, showing it to another switch, but in this case, it goes to an access point. It's going to be trunked to the access point. So we're going to have guests and staff tagged to the access point. And the access point is going to have 3 VLANs coming to it. It's going to have the on-tag and management VLAN, is how we're going to manage it. Then we're going to have the guest VLAN, it's going to come off one SSID. And then we have a staff VLAN, it's going to come off another SSID. And once it goes on the wireless, there's no standard tagging for wireless, and so it's going to come off on-tagged onto the wireless. It's going to be framed for 802.11, which is a completely different framing structure than the Ethernet. So let's log into the switch right now, and let's show you how this is going to work. Okay, so this is the switch we have, and it's a 5912, and we have one access point as a 360. As you can see, it's already hooked up. Let's go in and start configuring this for the VLANs. So first, let's start configuring the switch. So in the switch, we don't have the routers hooked up yet, but I'm going to hook them up. Let's set up the switch so that we could actually have those routers hooked up as access layers, and we could get those networks onto the switch, and then we could carry those onto the access point. So I click VLAN, and I click 802.1Q. When I click 802.1Q, that's basically going to tell the switch, this is how I want the traffic look egressing from your switch port, which is going out of the switch port. The PVID says, this is how I want traffic, on-tag traffic to look coming in to the port. So any that's on-tag is going to be placed on that particular VLAN. So in this case, I'm going to add VLAN 2 and VLAN 3. So let's add a VLAN, VLAN 2, let's call that staff. Okay. And I have to click OK there. Let me go back, and let me add VLAN 3. So now I'm going to structure it in which I want to have access layer ports, those particular VLANs, but I want to trunk it to the access point. So the access point is coming off port 8. So let's start removing VLAN 1 from where we don't want it. So in this case, we do not want VLAN 1 off port 1 or port 10. Okay, so now there's no longer any VLANs on port 1 or port 10. Now let's start adding VLANs to those particular ports. So let's say I want the staff to be on port 1. So I'll put that as untagged, okay? But I also want that tagged on 8 because that's going to the access point. And now I want the guest to be on 10 as untagged and 8 as tagged because that goes to the access point. So now we have the VLANs set up on the switch. Now let's have the VLANs set up on the access point. So let's come over here to the controller. I'll go access points. I'll click on device name. And let's go down to WLAN settings and let's start setting this up. Okay, so the first SSID, probably I want it as staff. So let me click here and let me click on 5 gigahertz only and let me click staff. I do believe we had it down as VLAN 2. Let me double check on that. Sorry about that. I should have wrote this down. 2 staff. All right. 3 guests. Sorry about that. Got mixed up, but let me go back to the access point. So now I'm going to set up this VLAN as staff, this SSID as staff on 5 gigahertz. It's going to have VLAN isolation, which means this particular SSID is now only tied to something that is tagged matching this VLAN ID. So let's go to, okay? And then let's add some security on that. Let's do some super secret password of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we have the staff on the access point coming out to 5 gigahertz. Okay, now I want a guest one as well. So let me click on the second SID. I want guest on 2.4. I'll label this as guest. And I also want to have VLAN isolation. And I'm going to isolate it to VLAN. Sorry about that. In this one, I want to add security here because in this case, I'm closer to a cafe. And if I just label guest as secure, I'm going to have a lot of people logging onto it. So let me start pushing this setting now out to the access point. Okay, so it's going to be pushed out. It's going to take about a minute or two for the device to actually apply the settings. Let me go hook up the network now. Okay. So now I have the network hooked up. Let me get my client devices. So I'm getting my client devices ready. So I can show you when I actually connect devices here, you can actually see in the user interface the devices connecting what IP address they are getting. So you could actually see that they're actually pulling from the network they should be pulling from. So now that it's online, let's go to monitor active clients. And we have no one connected yet, but we will. SSID, ban, it's fine. So let me connect the devices, okay? I'm connecting my cell phone to the guest. Staff is not there. There it is. Staff. There you go. So I can see that I have actually two of them. One's on 5, one's on 2.4. And these are the actual devices that are connecting to the network right now. I believe I go switch, layer 2, as you can see here, I also have traffic flowing through VLAN 2 and VLAN 3 off the particular ports. So you can see, sorry, that cuts right there. So you can see what ports they're coming down, and you can see what VLAN they're on. All right, so let me go back to questions and answers. Okay, so let me see about some questions we have here. We can answer some questions. So now in the question and answer section. Okay, we have some questions here. It says, is it recommended that when you do 2 SSIDs, 1 AP, that you have them on different frequencies like you set up? Well, I would recommend doing that for guests and for production, because basically the guest is not really there for high performance. And when you separate on separate bands, you're actually having 2 separate radios, so the guests don't have to share the same contention domain as your production. So if you have guests on the same band as your production, they're now contending for access to the same medium off a half duplex, which is wireless. And so if the guests are doing something and the staff needs to get something done, you have a higher statistical chance of missing frames. I just recommend separating out the guests on 2.4, because that's normally meant for coverage, and staff is meant for 5. And another person asked, I noticed checkbox for 2.4 and 5 gigahertz. Older versions have two separate drop downs for the config. Yes, you are right. I am showing you configuration on the controller 1.9, and that does change the user interface of the devices. So it's we do have other documentation showing the older one. So I want to make sure we make that clear and show you on the newer one. We have another one that says our smartphone builders building their devices with without 2.4 gigahertz radios. Pretty much no. 2.4 gigahertz is here to stay, no matter how many times people want to wish it dead. Before AX, actually, you want it dead, but now that AX is coming out, it's adding some pretty cool stuff like smaller, smaller bandwidths within the OFDMA and some BSS coloring. BSS is still going to be around. 2.4 is going to be around for a long, long, long time. The reason why 2.4 gigahertz is around because it's pretty much global. You can find it anywhere in the world. 5 gigahertz, it's hit and miss. Some countries you go, you have access to some channels, some of them you don't. And if the radio was for one domain, not another domain, it's carried one, a driver may not be able to see it, understand it. So 5 gigahertz still has some incompatibilities on it. So 2.4 is pretty much the most compatible band you could have. Okay, so then I have another one that says, if I choose guest network on the EnGenius AP, do I need VLAN to isolate, or will that traffic be automatically isolated? So when you choose guest network on the EnGenius access points, the EnGenius access points become a virtual router. It's not going to traffic segmentation at layer 2 at that point. It'll still be intermixed with the traffic on the primary network. So in order to have traffic that's truly segmented, so you do not see, if you do like a FING or layer 2 discovery, not to see anything you don't want them to see, the proper way to do that is with VLANs. And one thing is that a lot of people, the basic, in order to have a secure network, and security is a big topic nowadays, in order to have a secure network, the basic fundamental thing is understand how traffic is flowing in your network, and the proper thing to do is segment that traffic out. So no matter which way you slice it or dice it, eventually you're going to have to understand VLANs and how to implement them if you want to be able to have a more secure network in the future. Thank you for that question. They're all great questions. Okay, so I have another one right here that says, any issues using mesh networks, 6 to 8 APs? We normally don't recommend that many on one mesh domain. If you want to have that many, you may want to break it up into separate mesh domains and maybe 3 or 4 on one. That's maybe what you're running into in that particular scenario, because the mesh runs on one frequency, and the more you put on that frequency, the more it's going to raise your noise floor, and that's not going to be good for you. Because it still has the standard 802.11 arbitration process on that. Even though there's mesh behind the scenes, mesh does not change the 802.11 arbitration process on the radios. Well, our mesh doesn't. All right, so now we're going to, okay, so we have another question, and the question is, how would you configure ports for VoIP phones? Where you want the phone on a VoIP VLAN to be able to plug the computer into the phones that get placed on VLAN 1 native. So I believe what's going on here is basically there's a switch on certain phones, and on the phones themselves, you're going to send the tag traffic to the phones. So when you go to Cisco and you have a voice VLAN, or even on our switches, we have a voice VLAN, it identifies by the OUI. The OUI is now you're able to start prioritizing the traffic based upon the COS, because the only way to get the COS is 802.1q header, because the priority field is in that header. So that's the reason why when you add voice VLAN, it automatically adds a VLAN for there that you identify for that, because it has the 802.1q header in there for that priority field. So what you would do is you set up the phones to understand tag frames and just pass through the on tag to the computer. So it would be a trunk port at that point, and whatever one you want as the native would be the one that the computer connects to at that point, because that just gets passed through. Thank you for that. That's a very good question. It says, within multiple APs, what is the best practice for client handover between APs? Well, I don't. The best practice for that would be actually a proper Wi-Fi design. Now, there's a lot of okay. What is it? So there's a lot of different variables that go into Wi-Fi that pertain to this one particular topic. We talked about it in a previous webinar. We could always talk about it again if you're interested. If you have enough interest, we could go over it again. But basically, the long and short of it is no RRM, radio resource management, auto channel, auto power, is going to make up for a bad Wi-Fi design. And roaming is very heavily dependent upon the application that is running on the client. And it's very client dependent because client's the ultimate decider for the roaming. So we have a logic that we don't know fully because they want to have secret sauce for the roaming of the client as well as the application performance on itself. So a newer client may have better roaming algorithms, which may be able to handle much more robust or greater number of applications. And the applications themselves are understanding this, the application developers, and they're actually designing the application to be in a more non-forgiving environment in order for the application to be surviving. That's the reason why you're going to see vendor proprietary voice over Wi-Fi protocols dying, and you're going to see more standards-based protocols actually growing in the field, like the ones that Google use and FaceTime and such of that nature, because they're adaptable to what the network has available to you. Basically, the long and short of it is, once the capacity of the network gets exceeded by the demand, you have a higher statistical chance of having problems. So if the application is able to adjust its load based upon the capacity, then you have a greater statistical chance of the application surviving, particularly if it's real time. But that's a great question. Thank you for that. Okay, we have another question from another panelist. I believe they come from Latin America. They're saying, what is VLANs? So I don't know if you came in the beginning or the end of this webinar, but basically the easy answer is VLANs are basically just an 802.1 tag added to a header. Okay, we have more questions. We have one that says the end user device, example, the PC is not 802.1 compliant and uses VLAN 1 as default. I understand that the AP is handling the VLAN separation to the end user via SSID. How do you configure the switch such that when the PC is physically tied to a particular port on the switch, it will get the VLAN traffic assigned? Haven't much luck with it. It says, I'm too involved to take it offline. So in this particular case, you'll have VLAN 1. In fact, maybe if I could go back to the screen, I could show you what I have. So in this case, I just realized, let me do some stuff right now. So hang on, 1 is 2. So in this case, when you do this, the question that you asked is that when I have, like, for example, port 8 has this VLAN tagged and this VLAN tagged, as well as one coming down on tagged. So if the computer only understands on-tagged ones, that means the computer should get traffic in VLAN 1 only in this particular case off port 8. But if I want it to be a different VLAN, I got to remove VLAN 1 and place a different VLAN as on-tagged off that port, as well as change the PVID, which is over here, to whatever VLAN I want. And once that's the case, then I'm able to have that traffic pass through as on-tagged. But great question, thank you for that. Okay, so the other one is, question is, in this setup of guest VLANs, VLANs are broken out of the trunk port into different physical ports of the switch. Presumably you go from each of those ports to separate routers, correct? Yes, that's how we currently have it going on. You can also do router on the stick where it goes to 1. How would the VLAN config change if we wanted to run a trunk port carrying all the VLANs into a VLAN aware router? Okay, so in this case we would have it, as you would have something called a router on a stick, which is basically, imagine a lollipop. So you have a lollipop where you have a big circular head and then one shaft running down. That's how it looks like. You have one inter-VLAN router and one connection down to a switch. At that particular point, you would have all the tag ones running down that port to go to that router. The router, in its visual, it has sub-interfaces. In the sub-interfaces, that what it applies the VLAN tag to that sub-interface, and you're able to apply particular things like DHCP servers, different virtual DHCP servers to that sub-interface. So it would look like a sub-interface. So it would be like ETH 0.1, ETH 0.2. The normal naming convention would be, okay, ETH 0 would be the actual physical interface, but ETH 0.1 would be VLAN 1, ETH 0.2 would be VLAN 2, ETH 0.3 would be VLAN 3, and then those will go to separate subnets. So hopefully I answered that question. We have another one that says VLAN 1 is 192.168.10.0 in this case. No, actually VLAN 1, it is 192.168.3 in this case. That's going to be the VLAN that I have it on for the management VLAN. I know in the other ones it probably has different images, but this is the one we have set up for the actual demonstration. We have another question coming in. It says, elaborate on VoIP phones and computers, please. Was this example using a converged network where the PC is plugged into one into the phone and auxiliary port, not the network port? That would be equivalent to how I configure port 8. Port 8 would be equivalent to how you configure it for the phone. So you would tell the phone to look for this particular VLAN for the voice VLAN and the VLAN ID, and the other VLAN, in this case VLAN 1, would be the one that's on tag. It'll just be passed straight through onto the computer, and the computer doesn't know any difference between the tag and the on tag. It just gets the on tag delivered to it. If the tag do get duplicated onto where the computer is at, because of the FCS check, the computer is just going to silently discard all 802.1q frames. Hopefully that answers that question. This one says VLAN 2 is 192.168.20.x, but PC will not give the .20 address. Okay, so basically the question is here now, the DHCP. Now remember, the switch produces the pipes, and the services such as DHCP and routing is handled by your inter-VLAN router. In this case, a very easy thing to do is set one unoccupied switch port as an access layer port for that VLAN, and another one as maybe the same, or if you want it trunk, you have it trunk. Ideally, it'll be another access layer, and you start pinging across from 2 different computers. If they can ping across, you know that the VLAN is set up on that VLAN on that switch. The next question is, now you need to have that VLAN. Now that VLAN exists on that switch, it needs to go somewhere. So you need to make sure that that VLAN gets broken out of the switch, either tag or on tag, to somewhere else. That's probably what's going on. The connection, the VLAN connection between the switch and the router is either not there, or if it is there, that router doesn't understand what the VLAN tag is, or the DHCP server is not properly set up for that particular sub interface on that. So that's something you got to either contact the manufacturer of your router for, or if you need us to help you troubleshoot that, we could troubleshoot that for you later on. You just send the email to partners@engeniustech.com. That's a very good question. Thank you for that. All right, so it seems like we have another question coming in. The question is how to get access to the slide deck as well as this presentation. The recordings of the presentation are done behind our partner program, and also if you need access to the slide deck, you can get it from partners@engeniustech.com. And thank you for that. It's a very, 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 very good question. Okay, so it seems like that's all we have time for. Thank you for all your participation. Oh, I do have getting one more. Sorry about that. It says, would you need to reserve a port on the switch as on tag in order to have a spot to plug into the access for management VLAN? Yes. If the management VLAN is not carried through your switching fabric, then you would have to set up a particular port on the switch as a management port. You also, on our switches, have the option of doing the console port as well, which gives you access to management of it via CLI in the console one. So that's a very good question. Thank you for that. And yeah, that's one thing you need to be aware of, the ability to lock yourself out of the switch if you do that incorrectly. Thank you for that. That's a very good one. All right, that's all we have time for. Thank you for all your time and all your participation. And if you have any other things you want me to talk about, any other topics, just let us know at partners@engeniustech.com. Thank you and bye.